Hi everyone. So the problem that you have in front of you is if x squared minus 13x plus c is equal to x plus k all squared is a perfect square, determine the values of c and k. So essentially what they're saying is that this trinomial can factorize into a perfect square. In other words, it can look like the right-hand side where we have a binomial squared bracket. In order to illustrate how this works with numerical examples, I'm going to start off with another example that I'd like you just to think about. So if I gave you this equation that said x squared minus 6x plus 9 is equal to x minus 3 all squared, I'm sure that you would all agree with that. What I want you to look at is the relationship between the trinomial on the left and the trinomial on the right. So firstly, this value, which is our c value in the other example, is the square of that, because that's what you do when you FOIL. You square that last number. If we have a look at this number, that number is half of this number squared, just like when you're completing the square. So in other words, we can find this number first by halving the b value and then squaring it. So in this case, we'd say a half times 6 and then square it to get the 9. And we can then find the 3 by square rooting the 9. And what's important though is that the sign in the middle of the bracket there must match that sign. Okay, so with that in mind, let's go back to this example. So right, as I've just explained, c is equal to a half times 13 squared. Remember the 13 we got from there. We don't have to worry about the negative because we're squaring it anyway. So we know that's going to be added. For it to be a perfect square, it has to be added. So that gives us a value of 169 over 4 for our c value. And then remember the k value was simply the square root of the c value. So now all we need to do is root the c value. So k is actually equal to the square root of 169 over 4. And in this case, it needs to be negative 13 over 2. Okay, why negative? Because there we have a negative. So therefore, because there's a positive here, we need to have k being negative 13 over 2. If there was a negative there, then k would be positive 13 over 2.